Section 4.2, Natural Exponential Functions, Part 2. Okay, we are in Section 4.2 working with the natural exponential function. Natural exponential functions are base e. E, like pi, is 3.14. E is a special constant, 2.718. In Section 4.1, we learned how to compound interest n times a year. If we were adding in interest, say quarterly, we would plug in n is equal to 4. If we were compounding interest daily, n is 365. We're adding in interest every day for however many years the problem asks for. Okay, so our clue to use this one was the key wording: compounded daily, compounded quarterly. If it says compounded continuously, then we're going to switch to this formula, which is known as PERT. Principal multiplied by base e raised to the RT power. Okay, P, our principal, our initial investment. Interest rate R, remember that we always, or we must, turn the interest rate from percent to decimal. T is always in years. Okay, so let's look at our example. If $3,500 is invested at an interest rate of 6.25% compounded continuously, find the value in the investment after the given number of years. Okay, so we have $3,500 invested, so there's our principal. We have an interest rate R of 6.25%, so we're going to make sure to turn that into decimal, 0.0625 for our interest rate. Now here is what tells us which formula to use. Since it's compounded continuously, then we're going to use PERT. Okay, find the value after 3 years, 6 years, and 9 years. Okay, so let's get going. We have A equals PE to the RT. We have $3,500 invested, so we're going to fill that in for P. Then we're going to multiply that by E raised to the interest rate, 0.0625, times time, and for part A, time is 3 years. Okay, so let's get that put into our calculator. 3500, 3,500 was our initial investment. We're going to multiply that by E. Now, if you look right here, that's about the 5th row down on your calculator. Right above ln, you should see e to the x. Now, to get to it, I have to use the second button. So I'm going to hit second and then E. Okay, depending on the calculator, you may or may not have to put in your own parenthesis. For this one, I do. But in parenthesis, we need the entire exponent, 0.0625 times 3. Okay, so if we invest $3,500, we're going to compound continuously at an interest rate of 6.25% for 3 years. At the end of the 3 years, we're going to end up with $221. And this is money, so we're going to round properly, not 80 cents. We're going to round properly. This would be 81 cents. Okay, let's go to the next one. How about 6 years? Okay, so for part B, we're going to find the amount, but not for 3 years. We want to go for 6 years. So we're going to change this to a 6. Okay, so second and enter. Brings up previous calculations. All I have to do is go over and change that 3 to 6. And that gives us 5,092. Now rounding properly, 47 cents. Okay, so after 6 years, 5,092.47. Okay, 9 years. Okay, so I'm going to go ahead and use 9 years for part C. So the amount after 9 years, second, enter, brings up our calculation. We're going to change that 6 now to 9, and we would end up with $6,142.69. $6,142.69. Okay, so if we're compounding daily, quarterly, that's an N formula. So look for the key phrasing. If we're compounding continuously, then we're using the PERT formula. Which of the given interest rates and compounding periods would provide a better investment? Okay, so here let's look at A. For part A, we have an interest rate of 5 1/8. Okay, so let me hit clear. 1 divided by 8 is 0.125. Okay, so 5.125% or 0.05125 in decimal. Okay, compounded semi-annually. Semi-annually is a key word for N. N is going to equal 2. So I know I have to go to the N, the formula involving N, which is P 1 plus R over N raised to the NT. Notice we can plug in R, our interest rate. We can plug in N, our compounded semi-annually. And then it says which of the given interest rates and compounding periods would provide a better investment. We don't have time, T, and we don't have P, our initial investment. So what we're going to do is we're going to go ahead and just provide one for ourselves. And we'll be okay as long as I use the same value for both formulas. Okay, so let's go ahead and just make up a number. Let's say we're going to invest $5,000 for 1 year. Okay, so then we end up with A equals 5,000 1 plus 0.05125 all over 2 raised to the 2 times 1. Okay, so if we're compounding semi-annually, let's take our 5,000. We're going to multiply that by 1 plus 0.05125 divided by 2. And then we're going to raise that to the 2 times 1 power. So we're going to end up with 5,259, rounding properly, 53 cents. 5,259, 53. Okay, let's go with the second one, which is compounded continuously. So this is our keyword, continuously. We're going to use PERT, the E formula. A equals P E to the RT. Okay, so 5,000 was a number that we decided to use for our principal since it wasn't decided. E, interest rate, 5% for this problem. And then time, we decided to use 1 year. Okay, we have 5,000 times e to the 0.05 power. And so after 5 years, 5,256.36 if we round properly. 5,256.36. Okay, which of the given interest rates and compounding periods would provide the better investment? Okay, so about 52.59 here, 52.56 here, so this one would be the better. Okay, that is section 4.2, part 2.